Hello and welcome back to Data Analysis and Visualization. I'm Javita Christie, and in this video, I'm going to talk to you about different measures of spread in statistics. So let's begin. The three different measures of spread in statistics are range, IQR, and standard deviation. IQR stands for interquartile range, and we're going to go through two of these measures in this video, and then in the next video I'll be talking about standard deviation. So let's first start with range. Now, unlike measures of centers that only find out the center of a given data set, the measure of spread is all about how far the data is spreading from the center, how wide, how big the data is, what is the minimum value and what is the maximum value, so that we get to know how big our data is and how far it is spreading. So the range, which is the first measure of spread that we are going to study, is nothing but the covering that is done by the data, and it is the most intuitive measure of variability. It is very simple to find out because all you need to do is find the smallest data point in your data set, which is the minimum, and find the largest data point in your data set, which is the maximum. And once you have found that, you just need to calculate your range by writing range is equal to maximum minus minimum. So just subtracting the maximum value from the minimum, just subtracting the minimum value from the maximum value would give you the range. Now let's take a look at an example where we are calculating an actual range. So once again, I'm going to use the same data set that we used earlier in the previous videos, which is the Best Actress Oscar winners data set. If you would like to take a look at it, I have attached an Excel file down below in the description box. You can open it and see it if you would like to see the actual data. What it basically gives is, different names of different actresses and their ages and when they won an Oscar. And this data is from 1970 to 2013 of actresses who won an Oscar award for being the best actress. And what you see right here are the ages of those actresses. So there are basically 44 values here, 44 actresses. It's a list of 44 actresses, and these are their ages. So this is our data set. These are the different ages, and I want to find the range of this. So in order to find the range of this type of a data set, I need to find the minimum value here. And if you go through the Excel sheet or you just go through this data given here, you'll notice that the minimum is 21, which is for Marlee Matlin for Children of a Lesser God in 1986. So that is the minimum age. And the maximum age is for Jessica Tandy for Driving Miss Daisy in 1989. So there are two ages, 21, which is the minimum, and 80, which is the maximum. And now that we have these two ages, all we need to do is to subtract them and find the range. So the range is essentially 80 minus 21, which gives me 59 years. So this tells me how far my data is spread, how big the data is, how many different types of values are available. So I can say that there are values between which the maximum difference is 59 years. Okay, so this is how I can find the range in statistics using this type of data. Now, just like range, we have something that works in the same manner, but it is slightly different than range, and it is known as the interquartile range, which is also known as IQR. So now in this diagram here, you can see where the position where it is written IQR, the blue lines which are shown, and it is written IQR. So IQR is nothing but the range of the middlemost 50% of the data. So you have a whole 100% of the data, but you want to find the range of the middlemost 50%. Now this is not as easy as it sounds, because to find the 50 below or 50 above something is very easy, but to find 50% in the middle of something takes a little bit of calculation. So that's what we are going to see now, how to calculate the IQR, which stands for interquartile range. So it is the range of the middle 50% of the data. And you can see that that's why the highlighted part is the middle 50%. The range is the range from maximum to minimum. And we remove the 25% below the range, 25% above the range, and whatever 50% is there in the middle is the interquartile range. And we'll take a look at how to calculate it now. So assume that this is your data. This is my first step. So this is my data. And in order to calculate the middle 50%, first I'm going to calculate the midpoint. The midpoint is essentially the median of the data, which I explained in one of my previous videos where we talked about measures of center. So median is a measure of center. And so first from the data, I'm going to find the median, the middlemost point, by dividing the data into two parts, equal parts, and getting the median. You already know the process of finding the median. Once the median is found, the next step is going to be to find what I would like to call the median of the median. So we're going to find two quartiles basically. The first quartile we will call Q1, we'll just denote it as Q1. And you can see in this diagram that first what I have done is found the median, and then on the left side of median, whatever data I have, I will find the median of that too. So what I have done is whatever's on the left side, which is 50% of data, I have divided that into two equal parts of 25 and 25% each. And then I found the center of that data, that center of that thing, which is Q1, which is known as quartile 1. And that is my second step, finding Q1, which is the center of the 50% of data below the median or less than the median. Now, as the next step, once you have found quartile 1, in a similar way, you will be finding quartile 2. So that means this is the midpoint of the other 50% of data that is greater than the median. So whatever is greater than the median, you're trying to find the quartile, the midpoint of that. So again, dividing it into 25 parts, and 25%, two parts of 25%, and getting the quartile 3. So this is what we have done. And now if you can see, the data is actually divided into 4 parts of 25% each. Now your IQR, which is the interquartile range, is nothing but Q3 minus Q1. So what you have is Q3 minus Q1, which is the middle 50%, because you are taking 25% below the median or less than the median and 25 more than the median. And whatever data you have is now the middle 50%. And you also know Q1 and Q3, which are the points that mark this data. And that is why if you just subtract from Q3, Q1, you will be getting the IQR, which is the interquartile range. And that's how you can calculate it. We are going to see that with an example. One thing that you would want to note about this is how the data is actually divided. It depends on the median. So we know that when we have to find the median, the method or the calculation slightly varies based on whether you have an odd number of data items or an even number of data items. So in both cases, the calculation can be slightly different. So if you have n equal to 7, then the middle value or the median is going to be the fourth observation, and hence your data set is going to be divided. But in that division of 50% below and 50% above, the median is not going to be included, because median is going to be removed and then you'll divide into 50-50. But when you have an even number of observations, then we calculate the median, which lies between the fourth and fifth observations. So in that case, when we divide our data into 50% and 50%, we will consider the two values that we used to calculate the median also. So remember that if there are odd observations, we don't consider median in either of the two halves that we have created. But if there are even number of observations, then we would have to consider both the observations involved in the calculation of median and include them in the two halves that we are creating. Now let's try to understand how this calculation is done. This is the sorted data. And along with the sorting, I have also provided the index, the position at which a data item is. So for example, in the sorted data, 27 is at the 6th position. In the sorted data, 32 is at the 13th position and also the 14th position. Now that I have positions, it's easier for me to make my calculations. So once this data is ready, I can make all my calculations. And to do the calculations, we are going to find the median. So the median, as we know, because we have calculated it previously, we can find the median by finding the two middlemost values. Since there are 44 data items, the middlemost is going to be, because it is even, there are going to be two values involved in the calculation of a median. Once I found those two values, I can then find my quartile 1 and quartile 3. So in order to find quartile 1, I'm going to use 30 and 31, which are the 11th and the 12th observations. To find the median, I would have to divide this data into two parts. And as you can see in this table given above, the data is already divided into two parts, each containing 22 observations. So out of those 22 observations, if I have to find the midpoint, which is Q1, then that would be my 11th observation and 12th observation. So that is 30 and 31 respectively. I'm going to divide that by 2, and that gives me 30.5. So that is essentially the median of my first 50%. Now I need to find the median of my second 50%, which is the one below it. So to find the median of that, once again, there are 22 observations. So the middle points are going to be the 32nd, the 33rd observation, and the 34th observation, which is 42 and 42. So if I do 42 plus 42 divided by 2, it's going to give me 42 itself. So my Q1 is 30.5 and Q3 is 42. So in order to find the interquartile range, which is the IQR, I just need to subtract Q1 from Q3, which means I just have to do 42 minus 30.5, and that gives me 11.5. Once you have calculated these quartiles, Q1, Q3, and IQR, this will help you to detect outliers in your dataset, which can be done in this manner. This diagram that you see here is showing you what exactly an outlier is. So we saw already what an outlier is when we studied histograms in one of the previous videos. But now you're going to see how you can decide whether an observation is an outlier or not by performing calculations. So in this diagram, you can see whatever is in the middle is capital M, which is median. Next to that on the left-hand side, there is quartile 1. And next to that on the right-hand side is quartile 3. And then, of course, we have our minimum and maximum values at the end of the data set. And then we are trying to find the interquartile range. Now, after finding the interquartile range, basically, if you perform Q1, interquartile range we know is Q3 minus Q1. Once we've found that, if we find out Q1 minus 1.5 into interquartile range, IQR, then whatever space we get, which you can see in this diagram, the blue space after, or rather before Q1 on the left of Q1, that space, and the space that you will get by adding 1.5 times the interquartile range into Q3, the space that you get after that, that space together will form your area, which is sort of a safe zone. So anything that falls beyond that area, you can term that as an outlier. You can say that that would be an outlier. So that is how you can find out outliers by using the interquartile range. And I'll tell you more about this in the next video, where we'll also study how you can create box plot using this interquartile range. So I'll see you there, and thank you for watching.